Yeah, thanks everyone for coming and joining us for a privacy session. And today we will start with user experience of privacy. Privacy has been a very sensitive topic over the past few years, but the main problem of privacy was that it was not coming from user experience standpoint. So it was standalone, fragment experience that didn't allow mass adoption of privacy as a segment overall. And now, over the past few years, we've been working to make privacy usable and actually embedding privacy in your wallet user experience so you can access any transaction, any dApp on Ethereum, any EVM chains without sacrificing or fragmenting your user experience on main chains. So what Hinkal provides is privacy without UX friction for assets, transaction, and IP data. So we can start with the basics of privacy, right? Privacy started as a standalone coins, and then they moved to this experience on Ethereum where you can deposit assets and withdraw. And this is problematic user experience for privacy because you have to be desperate to really want this type of experience, because what you actually do when you make this transaction is, like, let's say you want to shield ETH. You first split the assets, right, to have equal anonymity, and then you have to wait for some time, and then after you wait, you have to withdraw, right? This experience is associated with capital inefficiency and additional clicks, right? So you cannot earn yield, you cannot swap or like make transaction as like that you want, and you have to click lots of buttons to make sure that your wallet has privacy. And Hinkal solves this problem. And again, another problem that I haven't mentioned now is anonymity set, right? So if your user experience is split and privacy is fragmented, it means that it's very hard to build anonymity set of shielded pool because you're just a fraction of end user experience of the customers. So Hinkal solved this problem in the most elegant way. We've been working to make privacy invisible. So it's a wallet level privacy that allows you for full privacy of your asset, transaction, and IP data with Store integration. So this is realized on the wallet extension level and with dual side account. So it means that you have private wallet, which is a shielded pool, and you have unlimited number of public accounts that you can attach to it. For private wallet, what you do is you use it for like any stateless transaction. And stateless transactions are transactions like swaps, like PT tokens on Pendle, or any other transaction that doesn't require your wallet and the history of your previous wallet. So whenever it's detached from the wallet, you can make any transaction. What is the example of stateful transaction? It's the borrowing, because your health factor actually depends on your previous transaction and the history of the wallet. And since Hinkal appears as a smart contract instead of you can be liquidated on behalf of someone else. So that's why we abstracted this user experience and split into two different verticals. You have shielded private wallet, that is unified wallet for all transactions you can make. And for stateful transactions, you have individual wallet that you split, that you create for these dApps. But then user experience is still holistic because we designed the system that prompts you to move in a seamless manner from private account to public ones and then shield back to the main. So the whole user experience is abstracted here. And from a functionality standpoint, as I mentioned, right, so you can keep any asset in full privacy. You can make fully encrypted transactions from Hinkal wallet to another Hinkal wallet, so the value is hidden, and no one can see your IP data. Our first flagship product is Hinkal Wallet Extension because of its composability and privacy. So we believe that privacy should be on the wallet level, and everything else comes downstream from your wallet, right? So whatever you access. This allows you to always stay private, to make sure that you can access any apps, to make sure that you can make payments. So by this extension, we are covering a bunch of use cases that are crucial for adoption of privacy because it's invisible. Another product that we are working on now is Hinkal Multisig. It allows companies to collaborate in a fully private manner where signatures are private as well. And Hinkal for developers, this use case, we specifically focus on payments, but it can be also enabled on a DeFi side where you can you can integrate Hinkal SDK to basically enable privacy for any type of payment solution or trading. That's what appears on-chain for all Hinkal transactions. It's Hinkal, outgoing transaction, which is a DApp in this case, and then it comes back to Hinkal, right? Between two Hinkal accounts, it's Hinkal to Hinkal, while you maintain full self-custody over your assets. And Hinkal SDK enables developers to three states. It's private to private. It's, sender is private, value is private, it's encrypted, and recipient as well. Public to private, which means that you can send someone your Hinkal link and they don't see what you have on your wallet, right? And private to public, right? So it's a very modular structure that allows you privacy for any use case within payments and trading verticals. And now I'm passing to my co-founder, Nika.
Hi, everyone. I will continue with respect to wallet architecture. I presented here a graph with the structure of our wallet. I will explain how it works. So the simple thing you can think is that all of us operate from the same address, doing transactions from the same address. For the outsider is the same person, but in reality we are different people who are doing these transactions from the same address. The core of Hinkal architecture is Hinkal pool, so it's aggregated smart contract where each of the user holds his funds. It may be RC20 tokens or NFTs that is contained in this pool. And each user holds a portion of this pool. For a Hinkal pool, we use UTXO-based architecture. So each user holds UTXOs, and some of UTXOs comprise the balance of each user in the pool. The crucial thing is users hold shielded keys, so it's additional keys to EVM that are outside of the system, so outside of blockchain. And users can claim ownership of the assets with this shielded private key. Let's think about controller and possible actions of the user. The controller will manage the interaction between the user and Hinkal pool. So, for example, when user wants to do transaction with Uniswap, there are three types of information that he needs to provide. First, it's a ZK proof of the ownership of the asset. So user needs to prove that he holds some funds in the pool. Second one is a stealth address. I will go back to stealth address a little bit later, but essentially stealth addresses allows us to provide privacy of the receiver. And the third component is the call data. So the normal call data you provide when you do transaction with Uniswap or other smart contract. These three types of information is passed to the relayer. Relayers are the third parties who submit transactions on behalf of the users. And once relayer submits this transaction, first thing that is done is that ZK proof is verified on chain. This Hinkal pool releases funds to the transaction. Transaction is done. Think about swapping in Uniswap, and the swapped amount is deposited to the stealth address provided during the transaction. And so the swapped amount is linked to the stealth address of the user, and all this UTXO is deposited to the Hinkal pool. This is a normal transaction in Hinkal. I would like to separate two types of transactions in Hinkal pool. Georgi mentioned it before. It's stateless transactions and stateful transactions. I will define it. So stateless transactions is transactions where the outcome depends only on call data. So the outcome doesn't depend on some state of smart contracts or the blockchain. Think about swap. When you do it with Uniswap, the outcome depends only. So the outcome depends on the call data. It doesn't depend on your some personal state hidden in smart contract. So with the same call data, you get the same result. And the second type of action is stateful actions, where the outcome of the transaction depends on the hidden state in smart contract. Think about when you stake on Curve and then get reward. Your reward depends on the length, the period length you hold the asset in the Curve pool. So your current outcome depends on the past history. This type of transaction we are called stateful transactions. For stateful transactions, users need to have history, so they need to have reputation. When you staked some tokens on a Curve pool and hold these tokens in the pool for, let's say, 10 days, the outcome of the reward depends on the length of this period. For stateful transactions, users have the smart contract accounts where they perform the actions and hold the history. But for stateless transactions, user can perform transactions directly from the pool. So for outsiders, it means that they cannot distinguish between two people who are doing swaps. Either it's a first person or the second person. The innovation we brought here is simple. So previously, all the interactions were done through adapters. Adapters were smart contracts designed for specific interaction. Let's think about Uniswap adapter or Curve adapter or Bifi adapters. People were writing adapters for each interaction. We abstracted it, so we removed all the adapters, so the users are making their transactions directly from the hidden shielded pool. For this reason, we introduced a different type of UTXO. It's called approved UTXO. So they represent approval state of the shielded pool towards some contract. Think about approved tokens to, let's say, Uniswap contracts. This is a different state than normal UTXOs that were representing the balances of the users in the smart contract. With this approved UTXO, users are able directly to approve some amounts of token towards smart contracts and then do transactions. For example, you first approve some amount to the Uniswap smart contract and then do swap transactions. Sorry. Now I will go to cryptographic primitives that we use in our protocol. So we start from the baby job curve, elliptic curve. We need this for cryptographic operations done in the Hinkal pool and also for stealth addresses, because we need to prove ownership of stealth address of the user. Second one is very standard Poseidon hash for ZK hashing. So when you do UTXO commitment, you need to hash some amount, ownership, and address, and to produce commitment that is stored on chain. And the third primitive is ZK Snark protocol, Growth 16, golden standard for ZK proofs for fast verification of the ZK proofs. Here I will go deeper to the stealth addresses and why they help us in the protocol. So let me give you a simple example. When you do swap in Uniswap, the amount is uncertain because there can be some other swaps before you in the same block. So you never know what will be the total swapped amount of the transaction. And this is important because you need to capture the amounts that you swapped and deposit back to the shielded pool. So users should be able to generate one-time addresses for each type of transactions, and this one type of addresses should be independent for outsiders, but should be linked to the same key for the owner of the UTXOs. And this is exactly what stealth addresses are helping us to achieve. Stealth addresses were implemented with respect to smart contracts accounts, EOAs, but they were not implemented within smart contract like is done in Hinkal, and this is what we're doing. I will briefly describe how they work. So everyone here is familiar with Diffie-Hellman asymmetric cryptography. So we have public key, private key, and we have some cryptographic operation to derive public key from the private key. Stealth addresses allow to have multiple public key for the same private key. So think about generation of public key for every transaction. For outsiders, as I mentioned it, they are not linkable with each other, but essentially they originate from the same address.
Okay, we are unfortunately at the time, so I'm wrapping right now. So it's we have a team of 20 people. Nika is CTO, he has PhD. I'm CEO. I was twice world champion in sambo wrestling. Graduated from Stanford and spent lots of time in investment banking and hedge funds. And yes, please download Hinkal on your money in any form of yield and make sure that your entry point to blockchains is Hinkal wallet. Thank you.